Hello and welcome back. Today I would like to show you the first time I took my 8x8 wheel dozer into the dirt. We'll see the first run, see what went wrong, see the second run and see what went wrong there. Okay, so let's watch the best of the first drive. As you saw, a couple of things went wrong. The linear edge shader broke, so I repaired that with solvent-based glue. One of the motor clamps also broke. I printed a new one that is more sturdy. I generally did some cleanup on the torque balance tandems. Wasn't as bad as I feared it would be. And then the biggest thing was I reconfigured the controls. You probably saw that a couple of times I wanted to raise the blade but lowered it, and the other way around. And I think that's related to that. For example, when I'm playing a computer game, I also have to play with inverted mouse. So I did that. I also put the main functions on the blade, so the raising and lowering as well as the left-right tilt onto the second main stick, just so that, you know, the fine control is much easier on that. So that made sense. And yeah, so let's see how the machine worked with those changes. So yeah, I think you can see it worked a lot better. The change control scheme definitely helped. There's obviously still some learning to do on my part. The second linear actuator broke, very similar failure, so I repaired that, but in the medium to long term I think I need to look at different inserts that do not create this circumferential stress in the 3D printed bore. Maybe some tolerancing to look into as well. You know, we'll see the next iterations. Hopefully will be better. You might have noticed that the ripper had a lot of play. I designed it without adjustability. Not ideal, but I just went up one tooth on the pinion, and that took up all the slack. So it is running very well now. But obviously that's something I probably should take into account for future assemblies. There are some tolerances on the tooth size and alignment, so I can do a bit better on that. Generally, so I was pushing downhill most of the time, very loose dirt, not ideal, and I did wonder whether the machine is too light. It's obviously 3D printed in plastic, which is a lot lighter than the steel that the original, or the inspiration I should say, to this machine is from. So I did some simple calculations using the data that is available on the Melroe M880 or M870, the predecessor. The differences between those two seem to be small. It's a bit difficult to find out. There's not a lot of data available, or at least I couldn't find it. I found the tire size, I found promotional material, but a lot of the weights seem to be rounded, and it's not quite clear what dimensions are mentioned. There, Melroe offered that, or proposed to use this machine in different configurations. So there is a little bit of guesswork in there. But broadly speaking, I designed my machine to be 1:32 scale, so that it fits with the with the other machines in this relatively popular scale. And it turns out that if I compare my machine dimensions and weights to the M870 inspiration, scale is roughly 1:43 scale. So that means that the relationship between blade size and weight, and therefore tractive effort, is broadly correct. It's just that I have scaled it down more and then put basically a 1:32 scale cab on that to make it fit with the other machines. Nevertheless, I do think it could benefit from a little bit more weight. So I have started a redesign of the wheels. So I use 3D printed wheels with Lego tires, and change the shape so that I can use big steel washers inside the tire. So you might know that some full-size tractors actually use water ballast or steel weights inside the tire or on the rim. So this is not too far off that idea. The advantage of having the weight in the tire is that it won't stress the simple brass bushings in the gear motors, but you still get the benefit of the additional weight and traction. Obviously the acceleration will be worse because you have to accelerate the mass both in a linear direction and rotationally. But I think for a dozer, even if it goes forwards and backwards and alternates between those two, that will be acceptable. It did work quite well on my big grader, so you know, just a few grams in that scale will do some benefit, I'm sure. I found the multi-degree of freedom blade quite difficult to control. The different kinematics are a bit more interlinked than on a grader. The controls are different as well, so that will definitely take some more time to get used to. I was a bit worried about the ground clearance with the in-wheel motors and the torque balanced tandems. That seemed generally to be all right. As I said, the dirt was really dry and loose, and a couple of times I got stuck or almost stuck. Was still quite acceptable. And then the remaining real issue, I would say, is that the way the skid steer works on this machine is not really satisfactory. It drives forward and backwards very well, turns very well, but if you try to combine those two to drive a curve of a larger radius, so you go forward and turn at the same time, it is a very on-off kind of driving. I'm not 100% sure why this is happening. The ESCs, the electronic speed controllers, seem to work very well if I'm only driving or only turning, so I can do that at smooth transition between slow speed and high speed. But the moment I try to combine those two functions, it doesn't work. I don't think it's my transmitter. I'm not sure if it's the ESC. I think it might be related to that all 4 motors on one side are controlled by one ESC. The ESC is not overloaded, but you might remember in the early days of competitive rock crawling in the radio control world, there was something that was called Clodstall. So the Clodbuster is a monster truck by Tamiya, and it has motors on the axle, so 1 motor per axle. And when people used these axles in their rock crawlers, they noticed that sometimes when one axle was heavily loaded and the other axle was spinning more or less freely in air, and they had one ESC controlling both motors, that their rock crawler would stall, hence clod stall, meaning that the heavily loaded axle would not rotate because the axle that was in air or lightly loaded was spinning. And I think that's related to the back EMF created by that fast spinning motor, basically counteracting the battery voltage. In the case of the clod stall, that is avoided by using 1 ESC per motor. In my example, that would mean I need 8 ESCs to control 8 motors. So there are some affordable and not too bad on size options that I have. But yeah, I'm going to try that out on a prototype so that I'm not tearing apart my existing dozer and then find out that no, that's not the actual root cause of that issue. So yeah, good fun driving this machine, and definitely some more food for thought for future adventures with that. Alright, so just as I was editing the video, the washers have arrived, M20 washers seen here, and I thought I'd just give you a few photos to see how it hopefully will work. So these are the Lego tires, large diameter on one side, small diameter on the other, and obviously I use that on the outside to give the impression of a more balloon tire on the earth mover. The wheel is 3D printed, conical shape, so transition to the larger diameter has very little overhang, so that prints very easily. For the new version, I have a cylindrical part on which the washers are stacked, as you can see here, and then I have a 45-degree overhang, so again that prints without support quite well. The tolerance on those washers is very coarse, so some of them barely fit, others are loose, but that's nothing that a little bit of CA glue or stacking a loose one between 2 tight ones, whatever, it'll work. The completed assembly we see here, and then in this view it's not quite clear, but there is sufficient gap around the gearbox to allow a printed housing. Yeah, it's not perfect yet, but I think it's very promising. A lot of weight. Theoretically, you could even stack 4 of these, but 3 is quite plenty in this scale. The outer diameter of the washer is just a little bit smaller than the inner diameter of the tire. I would have preferred a little less diameter on the washers to allow the tire to deform more. It improves traction and self-cleaning, but I think the added weight will overcompensate any problems with that. So as I was mentioning, I have some other investigations to do, prototypes to print, so I at some point will switch over to the company colors and print a couple of those wheels in white and see how that goes. All right, and now this is really the end of the video. Thank you for watching, and until next time, cheers.